In June 2025, two B-2 bombers took off undetected from Diego Garcia, each carrying a 14-ton bomb never before used in real combat.
Designed to penetrate rock, concrete, and earth before detonating deep underground, a total of 14 were deployed against Iranian nuclear facilities.
This is the story of how both parts were built, the bomb and the only aircraft capable of delivering it.
Bring it down easy now. Copy that, watching the guide marks.
Bring the segment down another 2 meters, slowly. Copy that, watching the alignment now. We are clear.
The thermal signature here is consistent with the ventilation shafts we saw yesterday.
Agreed, but the seismic data suggests a deeper cavity near this ridgeline.
As you can see, the surface blast creates a wide crater, but the penetrator reaches maximum depth before detonation, focusing the energy.
As you can see here, the conventional payload only achieves surface detonation, but with the penetrator design, we are reaching
For decades, strategists faced a key problem: how to destroy deeply buried targets unreachable by conventional weapons. The GBU-57 is not a typical bomb, but a high-strength steel penetrator designed to survive extreme impact and reach deep underground before detonating. Its fuse acts as a brain, detecting layers during penetration and triggering the explosion at the optimal point inside the target.
The completed penetrator casing is loaded onto the ceramic roller hearth. The heat treatment process will now begin.
With GPS-assisted guidance and control surfaces, it achieves high precision, even against hidden underground targets.
We need to verify the measurements on this GBU-57 casing.
The tolerances are tight, especially at this scale.
Straps are tight, ready to move. Clear on this side, Charlie. Start slow. Copy that. Moving now. Make sure the alignment is perfect before we move it. All right, ready to roll. Clear the area.
The B-2 bomber had to be modified to carry it internally, preserving stealth and enabling precise deep strike capability.
The analysis shows full compliance. Verification is complete. Noted.
Good work, team.
What's the readout on the stabilization fins?
We're showing green across the board.
Confirmed.
Finalizing the report now. Okay, easy now. Watch the alignment on the left rail. Clear on this side. Keep it steady. Slow and steady. Watch the clearance. We're almost past the threshold.
Right there, hit the top two first. Copy that.
Applying 75 foot-pounds.
Ensure the torque is set correctly on the forward lug. We need confirmation on the green connector bypass.
The trajectory simulation looks stable.
Check the resource allocation in Module 4C. Real-world tests against concrete and rock validate its true capability, proving its effectiveness beyond theory.
Okay, coming up on stage 3 now. Hold it right there. See that discoloration on the leading edge? Hold it right there. See that discoloration on the blade? Yeah, I see it. Logging the coordinates now.
See there, lock it up. Lock and secure.
Inlet's clear, no foreign object debris. Roger that. Control surfaces look solid. We are green on the checklist.
Bravo 2, you are stabilized in the contact position. Fuel transfer is good.
Roger that. Maintaining course and speed.
The penetration depth here is significantly lower than predicted.
Yes, and the fuse timing data confirms the early detonation.
The penetration depth is lower than the specification predicted.
Check the fuse timing on run 34. It looks significantly off.
Bird Priester, the thermal signature on this test shot is too high. We need to reduce the drag here.
All right. Adjust the taper angle on the fuse casing. It should stay stable.
The failure point is clearly localized here on the casing.
If we adjust the fuse tolerance, we can mitigate that stress spike.
Right. Let's revise section 3B for the next prototype.
The polished and etched cross-section reveals the steel microstructure, highlighting the prior austenite grain boundaries.
All right, hold it steady. Easy now. Clear on the left side. Send it up. Weapon secure. Bay clear. Bring it up 5 inches. Easy now. 5 inches up. Steady. Clear on the left side.
Ingress route confirmed. FL250 until the IP.
And the updated SA2D site near waypoint Charlie?
Suppressed. We hold the current profile. Let's go.
Ingress point confirmed. Watch the threat ring at Kilo 3.
Acknowledged. We stay below the floor here. Satellite path synchronized with the strike time.
Good.
The structural damage here is extensive. We should prioritize the crater analysis.
Yes, the depth indicates a high yield.
Check this reading on the port side. We have an anomaly.
Roger. Moving in for a closer look. The coating seems degraded here.
Hydraulic lift engaged, pressure steady. Copy that, Bay 1 clear.
The assembly line is clear on Sector 4. Copy that. We'll take it from here.
This is how the GBU-57 is made, a weapon designed to change the rules of the game. Subscribe and like. This is Global Arms Factory.